Moving on to 3.2, solving systems of inequalities by graphing. So systems of equations, the past couple of lessons, there are 4 different methods you can use, tables, graphing, or the 2 algebraic substitution and elimination. Solving systems of inequalities, there's one method. It has to be solved using graphs. And that's because for a linear inequality, you need to see the area of the solutions on a graph. So then the same thing for the systems of inequalities, you need to see that region. Solving a system of inequalities, as it says at the top here, means you're finding the ordered pairs that satisfy all of the inequalities. Systems of inequalities will either have infinitely many solutions, which you are actually showing by shading in the correct area on the graph, or it's also possible they'll have no solution, which we'll talk about as well. So this is review. You did solve systems of inequalities in Algebra 1, so just reviewing how to work through these. I realize in math a lot of the time you're using pencil. If you'll see when I work through these, I use different colors just to graph the 2 different inequalities, or if there's more than 2. So if that's helpful to you, feel free to do that. But first step is to graph each inequality and shade the correct area. Make sure, just as with equations, your inequalities need to be in slope-intercept form before you graph. And then you're identifying the region that is shaded for all of the inequalities. And that is the solution of the system. So the solution needs to be shaded in either darker or shaded in a different color or highlighted. I need to be able to see when I look at your graph, thinking ahead to the quiz when I'm grading these, I need to be able to clearly see what your solution is. If I can't really tell whether or not you think it's the solution, then you won't get the points for that. So it needs to be very clear, and I'll show that with example 1. So in this example, we're solving the system of inequalities. So I'm going to just pull out this first inequality, y is greater than 2x minus 4. It's already in slope-intercept form, so I can graph it right away. The y-intercept, the b, is negative 4, so I can plot that on the y-axis. And then the slope m is positive 2, which I could write as 2 over 1. So that means I'm going up 2, right 1, or down 2 and to the left. And remember when you're drawing in your lines for your inequalities that you need to pay attention to whether or not it should be solid or dashed. So should this one be solid or dashed? Dashed, and why? It's not equal to, yes. It doesn't have the or equal to. So there should be a dashed line for that one. And then I'll shade right away as well for this inequality. So when we graphed linear inequalities, how do we determine which part to shade? What was that, Maddie? Plug in a point to test. What point could we test? 0, 0. As long as your line doesn't go through it, that's the easiest. So test 0, 0 to see if it's a solution. So replace both x and y with 0, see if it's true. So I would have 0 is greater than 2 times 0 is 0, minus 4 is negative 4. True or false? That is true. So then which part do I want to shade? Yeah, on the left side or above the line where the 0, 0 is, because it's true. And then keep in mind, too, you're also going to be shading for your other inequalities. So you don't want to shade in super dark just yet for this one, but make it clear which part is shaded. All right, so then for the second inequality, I'll go through the same process. This one also is already in slope-intercept form. The y-intercept, the b, is positive 3. So I can plot that right away. The slope m is negative 0.5, which if I wrote that as a fraction, that's negative 1/2. And that way I can go down 1 and write 2. I don't have to worry about going down 1/2 and write 1. You could do that, but this way you can just work with integers and not decimals. And then should this one be solid or dashed? This one would be solid. It's less than or equal to, so solid line. And now you kind of ignore the other inequality when you're thinking of shading for this one. If I test 0, 0 again, because this line also does not go through 0, 0, I would have 0 is less than or equal to negative 0.5 times 0 plus 3 would just be 3. And is that true or false? That is also true. 0 is less than 3. So I'm going to shade now below that second line. Now I could shade everything, but what you're going to see is the solution is where both are shaded. So I'm just going to shade over the part that's already shaded below that line. So I'm going to shade in the solution area right away. So they would both be shaded in this part of my graph. So your two lines divide your coordinate plane into 4 parts. One of those 4 parts is typically your solution area. So again, it needs to be shaded darker or in a different color or highlighted. I need to clearly be able to see this is the solution area. If I can't really tell, if everything is just kind of shaded the same amount, I'm not going to know that you recognize that's the solution, so it needs to be clear. So nothing that you write for a solution for these, or for this one in particular, the solution is that part of the graph. It just needs to be shaded in. Questions on example 1? Okay, so I'm going to have you work through example 2 in your groups. And then like I did yesterday, I'll come around and I'll pick a group to have somebody explain or show theirs, explain what they did. So graph that system of inequalities and make sure the solution is clear. And as I walk around, if there's questions, please let me know. All right. Is it you, Lily? Okay, Lily's going to show hers. So check your graph and then make sure you're checking your solution as well. She'll explain. Oh. Yep.
So I started with the y-intercept as 5 positive, and then I just went up by ones. And then for the next equation, I went -4 for the y-intercept, and then I also went up by ones by that. And then I used my test points in 0, 0, and 0 is greater than 5 was false. So I shaded in the side that should be true. And then 0 is less than -4, and that's true. And so I shaded that part. And they never are shaded darker because they're on the other side, so I said no solution.
Okay, so leave that up there for one moment. One thing, I just didn't notice this on yours, Lily. So you have your graph correct. The only thing is, and you said this right, this would be 0 is less than -4, which is actually false. So you shaded it right. You shaded the right area. Just this part of your work isn't written right. But you still have the right graph.
Yeah.
So hers is shaded correctly. Make sure you do have a solid line for the first one, dashed for the second. And then, as she explained, the solution regions don't overlap. You have to write no solution. So a lot of you had the right graph when I walked around, but if you don't actually write no solution, you would lose a point for your answer. Because there isn't anything you should be shading in darker, they don't overlap, so you actually do have to write no solution. Were there any questions? And remember too, for no solution, if you make the empty set symbol, the 0 with a line or dash through it, that is fine. All right, number 3, we're going to actually go through together. This is one where you have to set up a system of inequalities, and there's actually 5 inequalities you have to write for this one. So I want to make sure we all get them all and you understand them. So it says, Mr. and Mrs. Rodriguez are driving across the country with their 2 children. They plan on driving a maximum of 10 hours each day. So typically when I read through a problem, I either highlight or underline what I think are probably going to be important pieces of information. If they're giving us a number here, maximum of 10 hours each day, that's probably going to be important. Mr. Rodriguez wants to drive at least 4 hours a day, but no more than 8 hours a day. So that whole sentence is actually probably going to be important. And then Mrs. Rodriguez can drive between 2 and 5 hours per day. So it says, write and graph a system of inequalities that represents this information. So when we, or before we write the system of inequalities, I'm going to define what my variables x and y actually represent. So what 2 quantities in this scenario would the variables be representing? What are the things that we don't know? So, well, how many hours? It is x and y are both going to be a number of hours, but specifically what? Yeah, so the 2 things we don't know is exactly how many hours Mr. Rodriguez would drive and Mrs. Rodriguez would drive. So x could be, I'll just put Mr. R's hours, and then y Mrs. R's hours. All right, so now we can go back and knowing what your variables are going to represent is important because now knowing what x and y represent, we can piece together our inequalities. So if I go back to that first part that I highlighted, the maximum of 10 hours. So they plan on driving a maximum of 10 hours each day. Anyone know how we can put together an inequality that represents a maximum of 10 hours each day driven by them? Okay, x plus y, so the number of hours they're each driving totaled. If it's a maximum of 10, should be less than or equal to 10. All right, and then the next two sentences after that are focusing on each person individually. So the next one says, Mr. Rodriguez wants to drive at least 4 hours a day, but no more than 8 hours a day. And that's only focusing on Mr. Rodriguez, which only focuses on x. So this can be written as two separate inequalities. If he wants to drive at least 4 hours a day, that means Mr. Rodriguez's hours, which are x, should be at least 4. And what inequality can represent the phrase at least? Something or equal to, I didn't hear if you said, yeah, greater than or equal to. So at least 4 would be 4 or more. But he does not want to drive more than 8 hours. So x should also be no more than 8. What inequality symbol would represent that? Less than or equal to. He could drive 8. So that really is two separate inequalities. You could write that as a compound inequality. So another way this could be written is showing that x should be in between 4 and 8. But recognizing a compound inequality does represent two separate inequalities. And then we can do the same thing for Mrs. Rodriguez. So two inequalities with y. She can drive between 2 and 5 hours per day. So the y values should be between 2 and 5. So that would be greater than or equal to 2, but less than or equal to 5. Or if we wrote that as a compound inequality, we would show y is in between 2 and 5. So that's where those 5 inequalities are coming from. So questions on those. Okay, and I know all of these problems are different. So just because this one has 5 doesn't mean any that you would be given would necessarily have 5. You just have to work with the information you have. And then, as always, ask questions if you have them. So for this grid, again, it's not pre-scaled in case you need to use a different scale. It is 10 by 10. Given the values we have, we're probably okay just counting everything by ones in this case. So we can keep the scale by ones. And really, if you're keeping the scale by ones, if you didn't label it, that's fine. If it's not labeled, I assume that it's being counted by ones. So now to graph all 5 of these, and then also shade the region that would be shaded by all 5, is what we're looking to do. So the first one, the x plus y is less than or equal to 10. If I were to get this into slope-intercept form to graph, I would need to subtract x from each side. So y would be less than or equal to negative x plus 10. So the y-intercept would be positive 10. And then the slope is negative 1. There's a negative 1 in front of that x. So down 1, right 1. And actually, if I keep going down 1, right 1, I'm going to cross the x-axis at 10 as well. So when I draw the line in, I can kind of just connect those endpoints. Solid or dashed line? Solid. And you could just draw it as a segment, not being extended through either direction. A negative number of hours for either person wouldn't really make sense. So you don't need to draw arrows at the end. If you did include them, it's not wrong. And then to shade, so I can test 0, 0. It's at that bottom left corner. I would have 0 is less than or equal to 0 plus 10. So 10, that is true. So right now, I have this triangle shaded in. All right, now for we'll actually graph the next two together. So for x is greater than or equal to 4 and x is less than or equal to 8. So if you think of these as equations, x equals 4, x equals 8, when you only have one variable in an equation, that's either a horizontal or a vertical line. So if it's x equals, is that horizontal or vertical? Vertical. A way to remember, if you haven't heard this, maybe it'll help. If I have x equals 4, I should be going through the x value 4 on the x-axis, and to go through it without going through all of them, I would have to be going up and down, so vertical. So I should have a vertical solid line through the x value 4 and through the x value 8. And then for shading, you certainly could test 0, 0 in both. Or to think about it, this means x is in between 4 and 8, so you would shade in between the lines. And I'm just going to shade over what was already shaded by my first line. So right now I have this trapezoid-looking figure that's shaded in. And I'm going to restrict that even more when I graph my next two inequalities. So that means the y is greater than or equal to 2 and the y is less than or equal to 5. These would be horizontal lines through the y values 2 and 5. Again, both solid, so I can draw those in. And the y value should be in between them, so the shading would be in between, and I'm shading over what's already shaded by the other three. So I end up getting this trapezoid figure here that I'll shade in blue, but also shade in kind of the darkest or the most clearly. Shade that part. So I should be shading between these two horizontal lines, so then where the other ones were shaded would be this piece. So this would be where all 5. Well, so everything from this line was shaded below, which is why I'm not focusing out here. And then I was shading in between the two vertical lines since x was in between them. And that limited it to this larger trapezoid that I had in purple. Yep, it's in between, yep, the 2 and the 5. You could test 0 for both, but if you kind of look at it, y should be in between, so it'd be in between the 2 lines. Are there other questions on the graphing or the shading part? Okay, one question I have for you then, with this particular problem, it said write and graph a system of inequalities, which we did. So that would be our answer. That's enough to answer the question. What I want to do is go a step further with it, though, so you understand if you were to use this for something, how it would be used. So can somebody give me, we said x and y were the number of hours for each person that they could drive to fit the system. Can somebody give me a number of hours they could both drive that would work? So how many hours could Mr. Rodriguez drive and Mrs. Rodriguez drive and know that it would fit the system of inequalities? 4 and 5. So Mr. drives 4, Mrs. drives 5. Oh yeah, either way. So how do you know that would work? Okay, so realize the shaded area, these are all the ordered pairs that are solutions. So let's say if Mr. Rodriguez were saying drives 4, Mrs. Rodriguez drives 5, if we were to check if that would work, we could find the ordered pair 4, 5 on the graph. And it is here at this upper corner, but because the lines are solid, that means the lines are shaded, if you want to think of it that way. So that means it is a solution. Or even if these were switched, if Mr. Rodriguez drove 5, Mrs. drove 4, that would actually be fully in the shaded region. Does So just realize that's what the shaded region actually represents. It's showing you the solutions that would work. Allie?
So there a specific answer, or can it be just
Any of the points in that area, yeah. And that's with any system of inequalities, you'll never just have one answer. You'll always have a bunch of answers that are in that shaded region. All right, other questions? Okay, then the last example, this is actually leading us into the next section, which is on linear programming. It's using systems of inequalities for linear programming, which that is where if you're given a situation, you can use a system of linear inequalities to find a maximum or minimum amount. So we're kind of just leading into it. I'm not fully going to get into those details today, but it says here, sometimes the graph of a system of inequalities will produce an enclosed region in the form of a polygon, and to find the vertices of the region, you determine the coordinates of the points at which the boundaries intersect. So this system of inequalities here is graphed. You can see the shaded regions form this triangle. So those intersection points, the coordinates, would be considered the vertices of that region. So what I would like you to do, this is question 4. It says find the coordinates of the vertices. So you need to make sure for your answer you're actually listing the coordinates of the vertices of the triangle that's formed by this system of inequalities. So for each inequality, you'll want to do exactly what we did in the other 3 examples. Graph each one. Think about where the shaded regions are and then where they would overlap. And the problem itself is giving you a hint that the 3 lines should form a triangle, and then you should see that that's what's shaded. So it is giving you that hint, but you should make sure as you're graphing it that you are getting it right. So graph those 3, and then find the coordinates of the vertices, the corners of that triangle. So I'd like you to work on this in your groups, and when I walk around, I'll have somebody show theirs, and everybody can make sure they have the right graph, they have the right vertices. But ultimately, you're starting with graphing a system, which is what we just practiced. So make sure your inequalities are in slope-intercept form before you're graphing. And then as you are working on that, your assignment is a book assignment, but you are going to have graphs, so I have graph paper for you. I'll pass that out. But do this example, because like I said, I'll have somebody show theirs so everybody can check. Stop it. I know people are working, but then they can check too. Stop it. All right. Allie is showing her she does have the right graph and the right vertices listed. So check where you're at with hers, but she can explain to what she did.
Okay, so it's a little messy and a little
quiet,
hard to
please.
tell, but first I just put all of the different equations in the slope-intercept form. And for the first one, you had to end up flipping the sign to get rid of the negative y, so that's why it changed to y is less than or equal to 2x plus 1. And then just the same process for the other two, figuring out the equations. And then I plotted them on the graph, and it's a little messy, but you can just see that what's left was the small triangle in the middle. And then for the coordinates of the vertices, it meant that it was where the points all met. And the first one was 0, 1, 1, 3, and then 4, 0. So it was anything in between there.
Thank you. I'm just going to freeze it just to keep it up there, but then you can move your sheet. Okay, so check. If you did not get the right graph, I'll keep walking around. If you have questions, certainly let me know. If you didn't get the right graph, check that you have the correct inequalities. The problem itself, I kind of said this before, did already tell you it was going to form a triangle, and so you could assume that's what would be shaded. Ultimately, with this type of problem, as we move forward, you would have to determine that the triangle is what's shaded. So I'm glad to see Allie still did test her points to figure out what should be shaded, and it turns out to be that triangle. And then you're naming the vertices, which are where the lines meet, so what forms the triangle. So that's up there for you to check. Like I said, though, I'll keep walking around. Let me know if you have questions. And then your assignment is a book assignment. If I kind of see everybody's good, I can switch to have the textbook up here. But you have the graph sheet. Everybody got one of these, correct?